In this video, we are going to discuss NAND and NOR implementations of Boolean functions. Most of the digital circuits are constructed by NAND or NOR gate. This is because the NAND and NOR gates are easier to fabricate with electronic components. In this module, we are going to look on how we can convert AND, OR, and NOT circuits into equivalent NAND and NOR logic diagrams. So the objective of the module is first identify different symbols used for NAND and NOR gates, convert AND, OR, and NOT circuits into NAND and NOR equivalents, to implement two-level and multi-level NAND and NOR circuits. These are the different symbols or graphic symbols of NAND and NOR gates. As you can see, the standard NAND symbol that we can see on the book is the first symbol. We call it an invert circuit. So ito ay basically isang AND circuit na merong inverter sa dulo. That is why it's called an invert circuit. So if we have here inputs A, B, C, okay, so we have function f that is equal to A ANDed to B ANDed to C, and we are just going to invert it. So that is what we call AND. The next symbol for NAND gate is what we call the invert OR diagram or invert OR symbol, wherein we are going to invert the input first prior to the output. So initially our OR gate will have A plus B plus C, but since the inputs are already inverted, we have A prime plus B prime plus C prime. Now if we are going to factor out the prime, we can have A, that is the invert of A, and the invert of plus is AND. B prime will be B, again OR is AND, that is the invert, and then C prime inverted would be C. So factoring out the prime will give us A, B, C quantity prime. So that is the two graphic symbols for NAND gate. Also, we have here the two graphic symbols for NOR gate. So that is NOT OR. NOR gate stands for NOT OR gate. So from the word alone, we have here an OR gate and we have here an inverter. So it's an OR, but we invert the output. So in an OR gate, we have A plus B plus C. Since we have an inverter, the next symbol for an OR gate is what we call invert AND. So just like our NAND gate, we also have an invert AND for our NOR gate. So it is basically an AND gate wherein the input is negated or complemented, NOT A ANDed to NOT B, and of course ANDed to NOT C. So if we are going to factor out the prime, we can have A plus B plus C quantity prime. And also we have here the three graphic symbols of an inverter. So the first is a buffer invert. The function of the buffer is to amplify the signal from the input going to the output. If we talk about inverter, kapag inverter naman, ito ay meron lang siyang bubble dun sa output. Now, isa pang example ng inverter ay tinatawag natin an invert. Meron lang siyang single input. Tanungin nyo, sir, saan tayo makakuha ng single input NAND gate? Basically, ang mga nabibili natin sa market is a double input NAND gate. Yung dalawang input mo, kinonect mo lang sa isang input, then parehas na rin itong diagram na to. Ganon din sa OR invert. Okay. Ang mga nabibili natin sa market, dalawa din ang paa niyan. Pero kapag pinagsama mo siya at nilagay mo sa isang input, they will function the same as an inverter. So these are the graphic symbol of NAND, NOR, and inverter. So kailangan natin yan para sa pag-implement ng circuit using NAND NOR implementation. Now, let's have this example. The function f is equal to a, b plus cd plus e. Now, the first thing that we need to do is to draw the original circuit based on the gates presented. We have here a ANDed to b, c ANDed to d, and the totality we have a, the output of this one, which is ab, this is cd, and of course we have e that is ORed together to form our function f. Then the next thing that we need to do is to convert it using the NAND OR invert implementation. So how are we going to do that? The first gate, we need to put an inverter here, or what we call a bubble, and of course bubble here. Next, we also have here a bubble that makes it a NAND gate and another bubble here. And now you can see, since E is just single input and E here does not have a bubble or an inverter, so what we need to do is to place a prime here and then a bubble here. Take note, giving a bubble in the same line will just cancel each other. This is what we call the noble negation. Yan. Then kapag gagawin natin yung NAND implementation niya, so convert lang natin. Okay, so A, B, C, D, and E. Kung mapapansin mo, ginamit natin yung single input na NAND gate for our inverter here. Kaya lang, tinanggal ko na yung nakalagay na prime dito. So this is already removed. Okay, so if we go back to our symbol, which is the OR invert implementation, yung isa sa mga NAND implementation natin, sinabi natin kanina, ay yung OR invert. So kung titignan natin yung output ng F na makukuha natin sa last figure, titignan natin yung output F sa last figure, we can have AB prime because that is already written in NAND gate, CD prime, and we have here E prime. So putting it here, this is A, B prime, C, D prime, and we have here E prime. Now, getting F, we have here A, B prime, ANDed to C, D prime, ANDed to E prime, and then we have here prime. So, kung ibabalik natin, i-distribute natin yung prime, the prime here will cancel this prime here, so we have AB. The invert of AND here is plus or, then the prime here will cancel the prime there, so we have CD. The complement of AND is OR, then the prime here will be cancelled by the prime here, so we have E. Now, so as you can see, the original diagram can be implemented using purely NAND gate, and the resulting output is still the same with our original function. Our points to remember: this small circle denotes a complement. Two circles in the same lines denotes double negation or double complementation. Hence, they will cancel each other. Now we have another example here. We have f, the function of x, y, and z, summation of minterm 0 and 6. So this is written in summation of minterm. So the first thing that we need to do is to look for the equivalent minterm. So that is 0, means that is minterm 0, plus we have here minterm 6. Now if we are going to get the function, kukunin natin yung equivalent expression, we have yung minterm 0 natin, that is x prime, y prime, and z. Kung nakalimutan, balikan lang yung previous topic regarding midterms and max terms. And of course, we have minterm 6, that is x, y, and z prime. So this is minterm 6. And then if we are going to implement it using a NAND or NOR inverter, so kung titingnan natin kung paano natin implement using yung standard, meron tayong AND gate dito, that is x prime, y prime, z prime, at meron tayong x, y, and z prime. Then they are ORed together, that is of course f. The next thing that we need to do is to place a circle here or a bubble and a bubble here. So this is just the same, they negate each other. Here is a bubble and a bubble, they also negate each other. And then of course, this can be rewritten using this symbol, since again, if we recall, this symbol is another representation of our NAND gate. Next, we have the NOR implementation. We have function here. We have A plus B, ANDed to C plus D, and then E. Now, pagkakaiba nila, dapat kapag ginawa natin yung NAND implementation, make sure that the function is written in the sum of products. Kapag NAND ito. Kapag NOR naman tayo, dapat naka-written or nakasulat yung function natin in a products of sum, just like this one. They are already in a products of sum. Now, first, we need to draw the equivalent circuit based on this original function. We have A plus B, we have C plus D, and then ANDed all together. We have A plus B, this is C plus D, and then we have AND gate here. So having F equal to A plus B, and then to C, D, and then to E. Okay, the rules on the NAND gate will be applied also in our NOR gate. So we can have a bubble here at the output and a bubble. So again, double negation, this will cancel out. A bubble here and a bubble here, they will be cancelled. And we have here a prime and a bubble, they will be cancelled. Going back to the previous slide, this function or this gate can also represent what we call a NOR gate. So this implementation is what we call the NOR invert AND implementation. And if you want to have a NOR, pure NOR implementation, you can have it like this. So again, if you notice, this gate here is a representation of an inverter. This is a representation of inverter. This should not be here. Tanggalin na natin ito. Yan. Wala dapat ito kasi in-invert na natin siya dito. We have here the next example for NOR implementation. We have here the function of x, y, and z, the summation 0 and 6. So the first thing that we need to do is to get the function for f. We do the corner mapping, or we can just recall, since this is minterm 0 and we have here minterm 6. So the function of which is x prime, y prime, z prime plus x, y, and z prime. Now, to implement this function using NOR gate, we are going to complement f. So that is f prime is equal to x plus y plus z. We have here prime added to y, added to y prime. Sorry na pagbaliktad ko. Plus x prime plus z prime. Then, i-drawing lang natin yung resulting function. Meron na tayong x, y, and z or together. Then, may bubble dito. C, may prime. Then, x prime, y prime, and z or together. Meron din tayong bubble dito. And then, of course, yung default niya, and kung titignan natin yung function niya talaga, meron lang siyang bubble dito kasi ANDed sila. And then, or na may bubble, or na may bubble. Okay? So, parehas lang sila yan. So, this, again, can be represented by OR gate. Now, if you want to get the function f, this one, na hindi siya naka-invert, then you need just to put an inverter at f prime. So, ito, again, is just another inverter. So, that is how we can implement a function using NAND and NOR gate. So, thank you. So, this is the end of the module. See you again next time.